Hi, my name is Robert Maier-Silldorff. I'm a lead developer at Iteratech, and I also write blog posts on medium.com. So if you're interested, just visit this URL. I've also added a QR code with one of my recent posts, and it's also the post that covers some parts of this presentation. So, what we will talk today, I will present the problem that we had or that the customer had and how we solved it. Then I will show you the plugin system and talk about it, what's a plugin and so on. And then we will move forward to the communication. And unfortunately, I cannot show you the exact implementation. I'm not allowed to show you the exact implementation, but I've tried to re-implement it, and I will show you the re-implemented parts. And all the Angular specials, and as Andreas already mentioned, this solution was not built a few months ago. It was built a few years ago. So I will give you a case study. What were the challenges and what did we improve? So let's move on. So there are various ways to build a system. So the first and the obvious one is the monolith. So you could have one team that builds an app or a system, and this is it's going to be, no, let me rephrase it. It's a good solution if your team size is pretty small, and you will reach some limits if you have multiple teams. So if you have one team up to 6 or 7 people, everything is fine. But if you have multiple teams, it will not scale. Another approach would be that you split the front-end and the back-end teams, or that you introduce microservices in the back-end. And there is also a front-end team. And the way we did it is that we created verticals. And when I talk about verticals, I mean real verticals. So they are completely independent from each other. I've seen systems that seem to be vertical, but in the database layer, they are tightly coupled. So I have also one application that I'm currently migrating, and it has, I think, 5 or 6 microservices, but on the database level, they are tightly coupled. So 3 of them use the same database, and not only the same database, but also the same schema. And that's not what we want. We would like to have a loosely coupled system. So I've also added the Conway's law, so that means the way the organization is structured, I mean the teams, directly influences the application or the system that one builds. So what was the problem that we tried to solve? We had a customer with several core teams, so I would say 3 or 4 core teams, and then there were also external teams, and each of them built their own systems, and everything worked fine. Also the external teams built standalone systems, but then we faced a problem. We wanted to integrate something with one of the core teams. So we had to communicate with one of the core teams. And one approach would have been that we just take the repo of the core team and say, okay, we will implement it for you and you will do the review. But actually, the core team itself has a lot of work to do. And so we wanted to have a loose coupled system so that the core teams don't have to do anything, or at least almost anything. Almost nothing, I mean. So we introduced a plugin system. Means that we add parts to the core systems, and this is done with microfrontends. But when we talk about microfrontends, it's not just the JavaScript, but also the whole communication itself. Means that it's completely standalone. You have a microfrontend, yes, there you have one JavaScript bundle, but it communicates with its own backend. So we have a backend for the frontend, and also its own database with its own database schema. So it's completely independent, it's its own deployment. And the way we did it is that we extended the core system with additional features. So how did we integrate it in the organization? Here you see an example of some teams. I'm part of the team 1. So I think we have built approximately 6 microfrontends, I mean plugins in this case. So as I mentioned, a microfrontend is not just the frontend itself, but a whole system. But we also built standalone applications, and other teams, they also added features, plugins that are added to the core system. So there is one big core system application for the customer, and this has around 10 or 12 microfrontends, I would say. But it's not the only host. I think now we are at 3 or 4 hosts. That's the one with the 10 or 12 microfrontends, that's the biggest one for the customer. So how do we use the term microfrontend? So for us, it's not the rectangular area. That means not a page is a microfrontend, but there are some specified extension points. Means here you can see in this picture that we can add a sidebar on the left side and also on the right side, or we can add the microfrontend that is just a button, and as soon as we press the button, something shows up. Also here, this area, there are some toolbars, and that's just the microfrontend. So, as I've mentioned, one microfrontend is one feature. It adds additional functionality, and this functionality is provided by one team. It's one JavaScript bundle, and there's also one deployment. There's no communication between the components, and I mean, the microfrontend itself handles the communication, and there is no need for any cross-team API. So now, what's the plugin? So the plugin is the whole microfrontend. As I said, it's a system. So it's not just the JavaScript bundle, but also the backend and the database. And this plugin is, I would say, mounted into the extension points. So there are some extension points already provided by the plugin system. One of them is the sidebar that you've seen. The other one, a toolbar or a main content. So, and in this diagram, you see the architecture behind it. So, there is the microfrontend library that we have written. And there we can send commands and events. And we just add this to the extension points. I will show you the code later. I know if you I can imagine that you're pretty confused now, but later on it hopefully will all make sense. So let's talk about loading of the plugins. So we have a config server with all the information necessary. Means that I need to know where the microfrontend is, where the microfrontend is hosted. So there's a URL directly where I can load the JS bundle. Then I also need some information. I need the information about what's the ID of the application, because somehow I need to check if the user has the right permission to use it. And then there are also some settings, because in the host system itself, there's a settings page. So there's an array with all the plugins available that will be read at runtime. And there is defined, is it available for the user, a small description, and so on. So the user has a whole settings file, and he can enable or disable the plugins. So as I've said, I need to know the URL. Then I have to check with the application ID if the user has the right permission to use it. Then I say, okay, perfect, he can use it. We will load the JavaScript bundle. The JavaScript bundle is hosted on an Apache server. And then there is a microfrontend loader that's provided by the plugin system. And then it is edited or appended to the page. So, and what happens then? So, as soon as it is added a script tag to the HTML, the first thing the microfrontend does is sending a command. So in this case, it's calling host communication service.init, and then it says, okay, that's my name. That's my name, and I want to register with the host. And if the communication is established, I say, okay, the first thing I want to do is I want to integrate it. So I want to embed the web component. That's my component. That's the root component that I would want to add. And that's the extension point that I want to use. So I want to be added to the navigation. And then I can add some payload. For example, for the sidebar, that I get a name for the sidebar or something else. And then I've also added a screenshot from the plugin system itself, or at least some part of it, where you can see how the embedding works. So I just built a unique ID. I need a unique ID. And then I create a custom element. And I add it to the list. And then I say, okay, now I want to send a command and add it to the host. Later on, I will show some code examples that this will make more sense. Okay, what are the pros and cons of this solution? First, I have a loose coupling. There's no much communication needed between the teams. There are predefined extension points where I can just integrate or mount my application into the host system. I have independent deployments. So I have my own deployment. I can work independently. I have a runtime extensibility. I've shown you that there is a list of microfrontends that's provided on a config server. So at runtime, this is loaded, and the microfrontends are added. And I have also a fault isolation. So if something goes wrong, the host application stays as it is. So it can perform as it has performed before. The contrast, of course, I have increased deployment complexity. I have the complexity to integrate the plugins, but if I use the predefined extension points, it's pretty easy. So at first, for the first teams that built or wanted to integrate to the host system, it was additional complexity that has to be integrated. But now it is pretty smooth to integrate other systems, as long as the extension point is the same. And of course, the debugging is harder, and also the error analysis. So let's talk about the communication itself. There are commands and events. So you've seen one command already, the embed command. So the microfrontend is loaded to the host system. It is added as a script tag, and then as initial command, the embed component is sent by the microfrontend to the host. So the microfrontend says, do something. I want to be integrated to your system with this extension point. And the host has to do that. The other way around, we have events. So the host says, okay, actually, let's assume that we have a list of tasks. The task has changed. Task changed is an event and is propagated to the microfrontend. And the microfrontend can react on that. So it knows, okay, the context has changed. It's a different task. I have to load or do anything. But it doesn't have to do anything. It is not necessary to react on each event. So how is it built? How does it look like, the microfrontend library? There are several parts, I would say. The first part is the core API, which includes commands, events, and maybe also the loading. But yeah, that's pretty Angular specific, I would say. But the core itself, the commands and events, they are not bound to any framework. So you could use it also with different libraries. But as the customer uses Angular for all the applications, we also built a microfrontend API for all the Angular applications. Means that we've added the services, Angular services, because you've seen that you have to create a command and send it. And there are some utility classes for you that, for example, you could say dialog service. I want to open a dialog. So you don't have to care what's the payload that I have sent, what's the name of the command that I have to send. There is just this one service where you just have to say, well, what you want to do. Yes, as I've mentioned, it's primarily focused on Angular, but of course, also other frameworks could be edited. But over the last couple of years, that was never an issue or a change request. But it could be done. So how does it work? Here we see that we have the host and the microfrontend that wants to be integrated to the host. So I've shown you this microfrontend library. This microfrontend library includes the basic commands and events that are used for all the hosts. But there are also specific ones, domain-specific ones. For example, in this case, the one that I've mentioned, if I have a host system that manages tasks, this is pretty domain-specific. So changing a task change event, that would be in this microfrontend API library. So there are two libraries. The one is the basic one that is used for all of them. And then there is one domain-specific API that contains all the domain-specific commands, extension points, and so on. Then we have to talk about the commands. There are two types of commands. There are permanent commands. That means that there is a replay subject behind it, because all the microfrontends are added at a runtime. And not each microfrontend has to load it on startup, or I mean, at the time the JavaScript bundle is edited, because it could also be the case that it is just a button. And just if you press the button, then another microfrontend or a component pops up. So one microfrontend don't have to be just one component. It can also create other ones. And then there are the transient components, commands. I mean, transient ones. So there's no replay subject. If the microfrontend registers too late, then it will not receive the command. And then there is one specific case. We've also added the possibility to directly send commands to the backend host. So the communication I've shown you is between the microfrontend and the host system, but the front-end host system. And now I want to directly send a command from the microfrontend to the backend. So I will do some REST call, for example. I say, okay, I've seen that the task has changed, and now I want to add a node, for example. And I say, okay, I have a add node command. I send it to the host, and the host knows, okay, perfect. I have this REST API. I know, okay, that's the payload, and I will just call the endpoint with the payload provided. So, okay, let's move on to the code. How does it all work together? So, the microfrontend itself, the core, has a host communication service. So it uses the host communication service. First, a custom event is sent to the host with a callback. And with this callback, the events can be sent back to the microfrontend. Because I need to get a communication, and the communication is done via callbacks. And the host itself has a store. In this case, it's a Redux store. And if something changes in the store, a data is changed, for example, the task is changed, this change is converted to an event. So I see, okay, the task has changed, I convert it to a task changed event, and this is then sent to the microfrontend. I mean, the microfrontend can listen to it. It's not directly sent. And then on the microfrontend level, there is also a store with behavior subjects or signals or whatever. And there the events are saved, or the data. So I will show you some examples. So what's the first thing? Yeah, I've shown you for the microfrontend itself, the host communication service is the key. So at first I call init and I say, okay, that's my ID, I want to register. Then what does it do? It says, okay, establish the communication with the host.
Excuse me, you make that a bit bigger?
I can do that. Let's see. Is that right? Better? Too much? Okay. So I want to establish the communication. And as I've already mentioned, the first thing I do is I send a custom event. So I say document dispatch event. And with this, I can send a custom event. And this custom event has a payload with the first command that I sent. It's the add microfrontend command. And this includes the ID and also some callbacks. So I want to handle all the events that are sent by the host. Okay, I will pass this with a handle host event. And then there is also a command handler that I'll pass. And I send this to the host. That's the only thing the microfrontend has to do. Perfect. So let's move on to the microfrontend service. So that's the service that the host has to use. So the host has to init somehow, or to say, okay, I want to be a microfrontend host. So how is this done? There are some interfaces or injection tokens that have to be provided. So I actually need to know, okay, I need to know about the events. So there's a host event source. That's just an interface, and the host has to implement it, where I can say, okay, I want to get the former events, so the permanent comments, not the permanent comments. I want to get all the events, and then there I have a stream with all the events that are sent, and also an init function. Yeah. The next thing is that I need to load the microfrontend somehow. I need to know where I can find the microfrontends. So there's another interface. In this case, it's the abstract class that the host has to implement. And here it says, okay, I need to get the configs. Okay, so let's have a look at how the loading of the microfrontend is done. Maybe I make it even just a little bit smaller so I can see more. Is it 40? Didn't I say 20? Can everyone read it? Okay. So go back to the load microfrontends. Okay. I just add an event listener with the event, and there is the source. I say, okay, perfect. I need to know what microfrontends have to be loaded, and then I just load it. Let's have a look how this is done. I load it. Then I say, okay, perfect. I have all I need to know. I have the JavaScript bundle. I create an element, and I add it to the body as script tag. And of course, I have a unique ID. Okay. And that's also the entry point where I can say, okay, let's check if the user has the right permission. So in a production system, I don't load it immediately. I have some checks before that. So I say, okay, I have some permission checkers where I can say, okay, the user may not have the permission to do that. And then I will not load the microfrontend. And the host itself has to call init, and there I say, okay, I get all the events and I subscribe to it and write it directly into this subject so that the microfrontend itself receives the events. So okay, let's have a look at the microfrontend itself. There should be a initializer service. Yeah, here you can see an example on how the microfrontend initializes itself. So here I say, okay, init, I've shown you the code, how the communication is established with the ID. Then I say, okay, if it is established, I send an embed command. I want to embed myself. And here comes the tricky part. I've shown you that there is a microfrontend library, and then there is also a domain-specific library. So in this domain-specific library, I have a store. And on the store, I have some getters. I can just subscribe to it and do something. So in this case, on the host, the task has changed. For the host itself, it was just a state change, but it converts it to an event and writes it directly into this service. And the microfrontend itself can subscribe to the changes and then do something. That's all the magic. So let's move on with the presentation. Yeah, there are some Angular specials. So how do we do that? I've shown you that there is one JavaScript bundle that is added as script tag. So I need to make sure that there's really just one JavaScript bundle. And by default, Angular cannot do that. That's the reason why Manfred Steyer built this ngx build plus. And with this, I can generate a single bundle. How does it work internally? It is a hook to, it provides a hook in this case, and a hook with Webpack. So Webpack provides a way to generate a single bundle. But as we all may know, since Angular 17, Webpack is not the default anymore. So default is ESBuild. But with ESBuild, I don't have the possibility to generate a single bundle. But it is still supported, it is backward compatible, and also stable. So Angular will support it for the next years or so. So there's no reason why Angular should not support Webpack anymore. At least for now. That's the info for now. Okay, let's have a look at the organization diagram. Why did we do that? I mean, we could have also used module federation. I mean, we use Webpack, but with module federation, we would have the same Angular runtime. So I could partly use it. I could partly use module federation and just use it for the microfrontend library. But if I do it as it is supposed to work, I would have just one Angular runtime, and all the microfrontends would have to be the same one. But in the case that we have implemented, every microfrontend can have a different Angular runtime. Means that there are systems or plugins that are written with Angular 16 or even older, and there are also plugins that are written with Angular 21. So that's not an issue. We have multiple runtimes. So you might think that this infects the bundle size itself, because all the microfrontends have their own Angular runtime. But actually, if we zip it, it's quite small. So one microfrontend has about maximum 500 or 400 kilobytes. So it's not an issue anymore. And there is, this is the microfrontend library that I've shown you with all the internals, and the customer uses also another library, and that's the platform library. And the platform library is used by all of them. So what's another contra of this solution? As you've seen, there are commands and events. And now I have multiple runtimes, multiple Angular runtimes. So everything has to be backward compatible. Means I cannot do a breaking change in the commands or in the events, because I'm not sure which version of the microfrontend library is used. So if I want to add some parameters that are necessary, I create another command or another event. I cannot do any breaking changes, because then everything would break at runtime. So the Angular specials, yes. I've shown you that there are multiple Angular runtimes. So how does it work with the zone? Are all of you familiar with the zone? Yes, perfect. Okay. So I don't have one zone for all of them. There are multiple runtimes. So I have to make sure that the host renders it correctly. So just as an example, I've already mentioned it. We have some utility classes, and one of them is the dialog service. And there I have a show dialog, and then I say, okay, I want to show a dialog, and on confirm, please do that. On cancel, please do that. So in this case, I have to make sure that it is rendered. And for that, I say, okay, this ng-zone run, I need to do this in the zone. Otherwise, the host will not render it. Yeah, maybe some of you directly think about zoneless change detection. So what happens if I have a zoneless microfrontend or a zoneless host? In this case, ng-zone run also works. So even without a zone, this code will still work. So let's talk about the challenges we faced. I've already mentioned it. We have multiple runtimes. So at first, the bundles seem to be quite big. And we have done some optimizations. There are various tools available to analyze the build, the bundle, I mean. But the game changer was just to enable the gzip. So on the Apache, we say, okay, content encoding gzip, and then it's pretty small. Then, maybe another point. I have mentioned that we don't use module federation. And I have a microfrontend and I have a host. And both of them have to include the microfrontend library. So at first, we wanted to use instance of to make sure which command it is. So we wanted to add some checks. If this is that command, then do that. And if it's the other one, then do that. And this doesn't work because we have two bundles. And the instance of does not work if you have two bundles. It just works if you have one bundle. So in this case, we have added some IDs to make sure that this is exactly the same command and exactly the same event. Otherwise, it would not work. Then we faced an issue. At first, we built the plugin system for just one host. And it was done quite often, so we added, I think, 4 or 5 microfrontends. But then another core team said, oh, that's a good solution. We actually have the we want to do the same. We also want to include some microfrontends. So how can we use that? And then we have added this microfrontend library that you have seen. So at first it was tightly coupled to the one host. Then we had to say, okay, actually there are 2 libraries. There's one general library that can be used by all hosts, and then there is another domain-specific one. So we had to split it. And everything worked fine as long as we edited the microfrontends, because we built it. We had a lot of knowledge about this microfrontend solution, but then other teams wanted to do the same. They wanted to add the plugins into their system, and then we became the bottleneck. So all the teams came to us. We have a problem. This doesn't work. This doesn't work. Can you fix it? And then we just realized, okay, we have to get rid of that. We don't want to be the bottleneck anymore. And then we came up with an idea. Okay, we create a reference implementation. So there is a reference implementation that's completely different from anything the customer does. So it's not domain specific. It's just, I think in this case, it's about journeys and travels. Just to show the use case. And there we have all the repos necessary. Means we have the host, the teams can have a look on how to get a host, or how to become a host, I mean, for the microfrontends. Then there is also another repo on how to build the microfrontend itself. Then there is another repo for the deployment. So there all is directly in the code, and all of them can access it. And this works because it is maintained every time a change is done. So I've shown you that there, next to the microfrontend library, there is a platform library. And every time this platform library changes, that is used for all the teams, also this reference implementation is maintained. So one challenge is that we had to force all the teams, if you do any change on the library itself, I mean the platform library, you also have to update the reference implementation. And at first it was quite a pain point, but over the years it's automatically done. Every team knows, okay, if I do a change, I also change it in the reference implementation. Okay, the next thing. The microfrontend itself, I mean the plugin system, it doesn't enforce Shadow DOM. So you have to say, that's my app component, and I say, okay, for this component I will add Shadow DOM. Because actually we want to add additional features to the host system. So in this one, in this case, there's no standalone application. It is just integrated into the host system. So I also want the same styles of the host system. So the host system must define how the UI looks like, as it is not a standalone application. So for most of our cases, we didn't enable Shadow DOM. But then other teams came to us and said, okay, it's a good solution that you add additional functionality to the host system, but we have a standalone application and we want to integrate the standalone application into another host system. And for that, we need a Shadow DOM because we have a different styling, and we have also other things, and we don't want style bleedings or anything else. And for that, I had to join one of the teams and take over the lead developer role and fix some libraries, because I've realized that not all libraries support Shadow DOM. There were some drag and drop libraries that we used that did some global changes on the document itself, or some queries directly on the document, and that doesn't work, because if you do something on the document level and you have a Shadow DOM, this is not visible for the application. So I had to fix one of the drag and drop libraries and also the dropdown. I imagine that ng-select works with Shadow DOM, but yeah, I had to fix it. But it works now. I mean, I've done it some years ago, but still. Yeah, so what did we do? We contributed to the libraries that we used, and we also patched components at runtime, because we have an older Bootstrap library, and in this case also some JavaScript has to be loaded, and the JavaScript that is loaded by the host itself, and the host itself cannot know the components inside the Shadow DOM of the microfrontend. So if the microfrontend is edited, I have to patch it. So in this case, it was a I think, a split button. So if you click on it, there is some JavaScript to open something. And I had to patch it so that it worked with the host system. And as I've already mentioned, I cannot do breaking changes because there are multiple Angular runtimes. I have to add different events or different commands. So there's no handshake. There's no version handshake. We did not implement it. I mean, with module federation, you could have this feature. You could have this handshake, but we didn't implement it. So what's another challenge that we faced? The deployment itself. So I would say consistency is the key. We use on-premise managed Kubernetes, and we have written a library for the CI/CD pipeline and also one to deploy the microfrontends. And just for the reason that it is quite simple for the teams to integrate it. So in the CI/CD pipeline, I can just say, okay, each team has its own namespace with the applications. This is my namespace. This is the application. I want to deploy it. So it's pretty simple. Otherwise, all the teams have to know all the Kubernetes stuff in order to deploy it. And we have broken it down so that it can be used quite easily. Another thing is the maintenance. I've already mentioned in this team, for example, we built 6 microfrontends. And these microfrontends also have to be maintained. I mean, we don't have to maintain it unless there is a security issue. But we want to keep everything in sync. So what do we do if there is a new Angular version? First, we update the platform library, because this is the one that is used for all the teams. So all the teams have to use it. Then we say, okay, we can update the microfrontend library and also the host system. So the host system is always the one that goes first and does the Angular migration. And then we can say, okay, perfect, the host system has done the Angular migration. Now the plugins can do it. All the microfrontends can switch or migrate to the newer version. And another challenge was that in my experience over the last 2 years, the team size rapidly changed. So the team size, there is a tendency towards smaller teams, I would say. Means that's just a few people have to maintain everything. And that's and therefore we came up with the idea to use monorepos. So we want to cluster something. Everything that is almost the same domain is put into a monorepo with an X. And the reason for that is that we have shared dependencies. So I want to update all at once. And if I use the consistent deployment, it is directly deployed on our dev stage and I can test it. So I do one change and I can instantly test it if everything works. Otherwise, I have to go into all of these repos and do it manually. And another good thing about NX is I can do the migration for multiple Angular versions. So for example, I'm here at Angular 16 and I want to go to Angular 21. I don't have to do it version by version. With an X, it's added to the migrations file, and then I can say, okay, run all the migrations and do it at once. And that's quite good for us and worked pretty good. So some improvements that we have done. One team came to us and said, okay, actually that's a good solution that you directly add the micro frontend when it is loaded by the host. But in this case, we want to do it differently. We just want to add the micro frontend if the user presses the button and also another key. I think the space key or something like that. So they wanted to add a hidden feature. And then they said, okay, if we refresh the page, the micro frontend is gone. Why is it gone? And in this case, if you refresh it, the JavaScript is the array with all the micro frontends is read again, and all the micro frontends are edited. But the one that is edited just if you press the button, the host doesn't know anything about it. So we had to add another command so that a register command means all micro frontends have to do the register as when the host loads it, so that the host knows about the micro frontend, and the host knows, okay, there was a refresh, and then it can just add it again. And then there is an ongoing change for the zoneless change detection. I have told you that there is just one JavaScript bundle, but there is also another file called polyfills, and within this polyfills, the zone.js is imported, and this is not edited by the micro frontend itself. Means the import of the zone.js has to be done by the host itself in our solution. So the host said, okay, perfect, I've upgraded to Angular 21. I will also do the change to the zoneless change detection, and then everything crashed because the micro frontends still needs the import of the zone.js, because there is no mechanism to add the polyfills to the JavaScript. Yeah, that's the reason why we change all the micro frontends to zoneless, and then if all are changed to be zoneless, then the host can say, okay, perfect, then I can also be zoneless. And what would be nice to have would be a version handshake, that I can make sure that the commands and events are in sync and nothing breaks. And another one would be that I can use modern bundlers, because there is a reason why Angular switched from Webpack to ESBuild. ESBuild is twice as fast, or maybe even faster. And I've already mentioned that ESBuild itself does not support a single bundle, but there are other bundles that does. And that's also some task that we will look into, because with other bundles it's possible. And there are also plugins for that. For example, NX has added a plugin for another bundler, and also other ones. And then in this case, Analog.js has also created a plugin for another bundler, so that it can be smoothly integrated with any Angular application. So, and that was all. Thanks for listening. Do you have any questions?
It's a time. Who wants to go first? Let's start in the front.
Sorry. Since all the plugins live on the same domain, I guess basically every plugin has access to everything that any other plugin is doing, like especially on local storage or cookies. Do you have any security mechanism in place, or is it basically by trust?
If it is added to the same host system, it's by trust. So there are no security check.
Mm-hmm. Okay, thank you.
Who's next? Yo.
So number one, thanks. That was fascinating and extremely informative. Too informative, probably, because I think there's a plume of smoke coming out of my lizard brain right now. But I think, so two questions. Number one is there a public GitHub repo where I can just look through this on in my own pace?
Not yet.
Okay.
I mean, we've built it especially for the customer. Mm-hmm. And also the customer said we cannot mention the name of the company itself. Yeah. So unfortunately not.
Sure. Okay. Then secondly, when you're looking at a monolithic application, right? Just a normal, good old-timey front end. What kind of questions do you ask yourself, considering whether this type of like very vertical microservice architecture is fitting for this application? Is it something that's just specifically operative regarding how the teams are structured themselves, or does it have to do also with the architecture of the system itself?
Yeah, it has completely have to do something with the organization and how the teams are structured. So in this case, we have built it to be completely loosely coupled and to scale very fast. That means multiple teams can add microfrontends independently of each other, and there is no communication overhead. Mm-hmm. So if you have multiple teams, so in our case, I've shown you 2 or 3 teams, but for real, there are more than 10 teams working on microfrontends.
Sure. So you don't really have like a roster of questions when you're looking just specifically the architecture of the system that you ask yourself, hey, would this kind of vertical microfrontend structure make sense here? But rather just specifically, I need to make several teams operate on the same application. Okay. Thank you.
So regarding trying to maintain multiple versions of Angular, as how I saw, I can imagine in a non-monorepo, but like multiple repositories, it makes sense. But if it's a monorepo, do you still do it in a way that you are using different kind of web components, for example, with Angular elements, or do you have multiple entry points for a package system that is doing the job, or multiple bootstrapped applications next to each other? Or you didn't really consider using multiple types of Angular in a monorepo version?
No, we didn't really consider it. All macrofronts in monorepo have the same Angular runtime.
Mm-hmm. All right, thank you. Because I'm interested, we have a monorepo and we always struggling with updating the version altogether, and we want to have somewhat similar, but but like partially migrate to a next one, which this is why I think, for example, like a separate bootstrap application, because you can also define which one is using zone/change detection and which one is using the zone itself.
But if I understand it correctly, in their case, that's why they started using monorepo.
To not have this. Yes.
Yeah.
I mean,
Coming from the exact different direction.
yeah, exactly. Yeah. All right.
But that brings me to another interesting point, because we don't share anything, or let's say we want to share as little as possible, means that if we have some micro frontends that almost have the same logic, there is nothing shared between them, not a single component. It's completely copied. So to be completely independent of each other.
Yeah. Yeah, this is also what we are aiming actually. So, thank you.
Who wants to go next? Just first.
Thank you. Is it working? My next question is, I am sitting in the very back. I didn't get some information. Just what would be the difference to web components? You use before you switched to monorepo with NX. You told you were using also micro frontends, and I assume the micro frontends were independent projects, if I assume it correctly. And what is the difference to web components? Your solution and web components, what is the difference?
Yeah, I think I missed or I didn't mention it. I can have a look if it is in the code. Embedded component, maybe elements, Angular elements. Yeah, so the web, we are using Angular elements to create a web component. That means each plugin is a micro frontend or an Angular element in this case, yeah.
So basically, you created a component, and
Yeah.
you first it will be a JS code, and then this JS code you use from a large application.
Yeah, the difference is that
So compile and then use it.
yeah, it's compiled as web component, but it's not a single component, but a whole application itself. And with the bundling, also the Java runtime is added.
Okay.
But it's still a web component, so I can also use it for other applications.
You have Java backend edited because it's default Java backend, because frontend calls Java backend via API, or because you also extra bundle it. Like, what I mean is it bundled because your web component calls Java APIs, or is it bundled because you do it extra somehow? Like you bundle also backend application somehow?
No, in this case, we load just the JavaScript bundle. So we create the micro frontend. We are using Angular elements for that. And it's not a small component, but a complete application itself. But there's nothing else bundled, just the JavaScript, the frontend itself. And this frontend communicates with its own backend.
Okay,
So there's another config parameter on the config server, and the micro frontend itself doesn't know anything about the backend. It gets notified, or it retrieves the information. Okay, what's the URL that I should use for the backend?
Okay.
So there is no direct link between those two.
Okay. Oh, I got it.
You.
When I understand it correctly, you have different Angular runtimes, but only one zoneless, one zone in the browser. When you have different zone versions depending to the Angular version, do you have any problems with that?
So far, we didn't have any problems. Yeah.
Because that was my biggest fear. I built a same system, and I built my host as a vanilla JavaScript to only have one Angular runtime in the view, because my problem was the different zone versions. But when you don't have a problem, it was the fear from that. I don't have a problem
you're
with
right,
that.
yeah. That's also the case. I've shown you this dialog service. So you have to make sure that everything runs inside the zone. So if you have something from the microfrontend to say to the host, and then the host has to render something, then you always have to make sure that this is done in the zone. Yeah? Otherwise, the host will not render anything. But then it works, yeah.
More questions?
Have you experienced any issues with using custom route reuse strategies? Because I've noticed that web components or custom components are usually destroyed once you detach the view.
Yeah, good question, yeah. Yes, the microfrontend library also comes with components itself. And one component is the microfrontend wrapper component. And there I can just say, okay, this is my ID, I want to edit. I mean, the bundle is already edited to the body, but I say, okay, I want to make an element of it. I want to add it as component to my host application. And so I'm sorry, I have lost my my sentence. Can you please repeat it?
So from my experience, we use custom route reuse strategies for like tabbed experience. You have like tabs, and when you have custom elements on one tab, and you go to the other tab, the other view gets detached, and you jump back to the original tab, the custom element is gone. And it's not recovered at all. There was some GitHub issue. It has been resolved in like 5 months ago, but especially if you're using Angular 21 and even older versions, this might be an issue, right?
Yeah, you're right. Now I'm back to my sentence. Okay, so we have created a wrapper component for that, and each time I navigate to the sidebar, the component is recreated.
The wrapper component, the whole wrapper component.
The whole wrapper component itself is recreated. So if I navigate to another page, it is detached. And if I go back to the sidebar or the application, then it is added again.
But I think there was no proper event in the life cycle until now. So this might lead to leakage, right? To memory leakage.
Could lead to memory leakage. That's also why we've added another component, a visibility component, because we've seen that there are some styling issues. So if the web component is created again, the styling, or I mean the CSS, is not in the right order. That's somehow the issue that we had. And therefore, we added the visibility component, and the host system makes sure that it is never destroyed. So it's never detached, the web component itself. And with the visibility, I just hide or show it. But the host system itself has to make sure that it is never detached. Yeah.
Okay, so if you update at some point, I would be interested to learn whether this solved the issue and made the other components obsolete, because this would be, I think, very good to know.
But we didn't face any issue with that, other than the styling issue,
Okay, one more question if there's time.
Oh, right.
You said, or I understood that you use micro frontends and micro backends, basically, other microservices for each slice. So you have like horizontal aspects like logging, caching, etc. So those are enforced on an operational level or like guideline level, so that every backend uses the same library patterns, etc. Or how did you solve this?
Yeah, I've shown that there is a platform library for the front end, and the same is for the backend. So we have a backend platform library, and everyone uses it to make sure that the logging, all the security stuff, and everything else stays the same.
And if you just adjust cross-cutting concerns, everyone has to change it, or do you not ever introduce breaking changes there as well?
Breaking change in which way?
Why you change the logger, or maybe, I guess you have interfaces for logging, but if you extend it, if you need more, or if you have to change the signature of some of these cross-cutting concerns.
Yeah, you're right. Yeah, if there are cross-cutting concerns and I change it, I have to change it everywhere.
So you prohibit it on an organizational level, or do you just say, okay, guys, everyone, we have to change this?
On
Because
an
in the-
organization level in this case.
Okay. Great, thanks.
Thank you. 1 second. Here you go.
What is the main aspect that you want one bundle? It is the different web context, or what is the main concern to have one big bundle?
No, it's the architecture itself. So I've shown you that the bundle is edited as script tag, and for that I need just one bundle. I mean, I could also do it maybe
with models. You can add different script tags at one page.
Yeah, we could do that. Yeah, but we also wanted to be bundler agnostic. I mean, in this case we use Webpack. Yeah. But I think that was the intentional reason behind it, that we wanted to have one JavaScript bundle so that different teams could use different bundlers. And the only thing that has to stay the same is that there is just one bundle there. But you're right, yeah, we could have also done it with models.
It also would be relatively easy to change it, I guess, because I'm doing it on my website. Instead of configure the URL to the JS file, you could simply configure a URL to a manifest file or whatever. Basically the same, I guess, as what the version is doing, I guess.
Yeah.
So you don't have the URL to the JavaScript file, but to a manifest file with, I don't know, 3 or whatever URLs.
But how do you do it with the polyfills? Do you also add the polyfills?
I add to my web components the polyfills in the main tiers. The import in the sound test in the main tiers, and everything that is in the polyfills add first in the main tiers, then it works. And they're built with width and as models.
Right, any more questions? One more. Here you go.
Since you've been at that project for quite some time now, maybe the obligatory question, what would you do different if you could start from scratch again?
Yes, good question. Yeah, what we could. I think we would start with the reference implementation, because we had lots of communication overhead with other teams, or I even had to take the lead of some teams so that they could generate or build their own micro frontend. So I had to help them with the skeleton, and then they could work independently. So I think that would be something that I would change. that I would instantly create a reference implementation so that everyone can follow the architecture and know what to do.
All right. Any more questions? Yes.
Just a small detail. I think I got it right from Ian. I could partly follow the skimming of the code. You load the script tag. And then the question is, how do you establish a shared reality between the host and the code running the script? It didn't look like you passed code around. I read custom events. Is that the mechanism?
Yeah, the mechanism is the first thing that happens is that the microfrontend itself sends a custom event with a callback to the host. So, I mean, you have seen a callback in the payload. If you send a custom event, you can add a payload. And in the payload, there is a callback. And then the host can send the events to the microfrontend.
I would guess the callback would get a reference to the custom element to work in then.
Mm-hmm.
Okay.
Thank you. Right. Any more questions? Last chance. All right. Here you go.
Testing would be my question. So obviously, when I build a microfrontend, I would like to have a test that it works against any host. And as a host, I would like to know if all my existing plugins still work if I change something.
That would be great, yeah.
Okay, so it's not there.
No, it's not there. I mean, I've mentioned that we have taken interest into monorepos, and if I use monorepos, I make sure that to have a high test coverage, because I have multiple microfrontends there, and I want to make sure that everything works as it worked before. So in this case, I have a high test coverage, but there is no integration test.
Exactly. The thing is, in the monorepo, like the compiler is helping me anyway. The very interesting and very valuable thing would be the runtime, find the runtime problems. Yeah. Because they're obviously you want to be decoupled, so you have runtime issues maybe, and integration tests would find them. Yeah. So. Yeah,
that would be great, but at least we deployed to the dev stage, and then someone can manually check if everything works fine. But yeah, sure, yeah. In this case, the customer explicitly said, okay, there should be no front-end tests. We don't pay for front-end tests. The business logic is in the backend. There should be only backend tests and backend integration tests. But I would love to do that, yeah.
Yeah, cool thing is the API is stable anyway, right? You don't want to change it too much, so shouldn't introduce too much problems.
But it happens that someone did a breaking change before we moved on to production, but on the stage before production, we noticed it, and luckily we noticed it and we changed it, yeah.
Any more questions?